Hey Chan Physics, this is Mr. Block, and you get to see me with my glasses on Wednesday. I'm trying to keep my contacts out. Anyway, so I'm trying to do this first problem for you guys. So in the Go Formative, this is problem number one. So this is Go Formative 2.10, and this is problem number one on the screen. So I just want to show you how to do this. So what we remember was we had three main points in our presentation on graphing. One, position versus time graph, slope is speed. Number two, in a velocity versus time graph, slope is acceleration. And this is the third one now. So now the third main point of that presentation was that in a speed versus time graph, which we're showing right here, the area under the curve is the total distance traveled. Okay, and so when you see this question, right, determine the total distance traveled in each graph. Remember what we're trying to do is we're trying to figure out if we had a speed versus time graph like this, how far does that vehicle go? Or how does that far does that runner go, or whatever it is that's going? And what we can do is we can just find the area. Now remember, the reason why we can do that is because we had this equation, V equals D divided by t. That's the first equation that we learned. And if we were to multiply that on both sides by t, right, we get this equation, t times v equals distance. T times the time times the velocity equals the distance. And so if you see right here, when we find the area under the curve, all we're doing is we're multiplying the time times the velocity, and then we get the distance. So how do we do this? Well, what we need to do is we need to get an idea of how can we break this into little chunks where we know what the area is. How can we find common shapes that we know the area? And what we see right here is this is a little too complicated, but if we were to just simply take a line and draw it right down here, well, now we'd have rectangle number one, rectangle number two, and square number three. And so if we were to look at these, now we can look at these pretty simply and say, okay, what's the area underneath this part of the curve right here? Well, it looks like to me like 20 times 30. So area for number one is 20 times 30. Okay. So the area for number two, well, it looks like 20 to 30 is 10, right? So there's 10 here times 60. So this one will just be 10 times 60. And the last one here, 50 to 60, that's 10 times 20. So 10 times 20. All right, so those are the areas. So we can, to find the area under the total part of this curve, right? Because there's nothing here. All we have to do is add those up. So 20 times 30 is 600. So that's for area number one. 10 times 60, that's another 600. So that's area number two. So we'll add that 600. We'll add that. And then we'll add the last one, 10 times 20 is 200. So we'll get a total right there if we add, sorry about that. 600 plus 600 plus 200, and we get that, we get 1,400. 1,400 what? Remember, we're looking for a distance, and since this is in meters per minute, it's going to be 1,400 meters. Okay, that's number one, and we'll do a little bit more complicated example for you later in this Go Formative.